Today we're going to so close transformations of rational functions. We're going to write these expressions as a product of linear factors. So here we can factor in x from both terms, which leaves x times x plus 1/2. Here, three terms, we see x squared, that's 2 parentheses. We know x and x. Now we need to figure out what numbers multiplied to give you -3 combined to be 2. Since the middle number is positive, the bigger number is positive. So -1 times 3 is -3. -1 plus 3 equals 2. So we have our -3 and 2. So our factors are x minus 1, x plus 3. Here, 2x minus 3 squared expands to be 2x minus 3 times 2x minus 3. Okay, now when there's 4 terms, we factor by grouping. So we can factor out an x squared from both terms, which leaves x squared times x plus 2. And the only thing we can factor out from the last two terms is -1, which leaves 19x plus 20. In order to be factorable, these two terms have to be the same. Since they're not the same, number 4 is not factorable. All right, let's take a look at the next page. Getting started. That graph looks a little shifty. You know that transformations performed on any function f of x to form a new function g of x can be described by the transformation function form g of x equals a f b of x minus c plus d. Recall that this transformational function generalizes to any function changes to the a or d values. Dilate, translate, or reflect a function vertically. Changes to the b or c value dilate, translate, or reflect a function horizontally. For a rational function, consider the form shown. R of x equals a parentheses 1 divided by b times x minus c plus c. All right, go ahead and mark this section off. We're not going to cut out the graphs. We're going to do something a little different. Activity 2.1. Transforming rational functions. You have studied only a small subset of rational functions. Let's consider the structure of the rational functions that you have explored so far. 1. Describe the effects of changes to the c value and d value on each characteristic given f of x equals a parentheses 1 divided by b parentheses x minus c plus d. A. Domain. The c value shifts the function horizontally. This changes the domain by changing the location of the vertical asymptote. B. Range. The d value shifts the function vertically. This changes the range by changing the location of the horizontal asymptote. 2. What determines a vertical asymptote? When does a rational function have more than one vertical asymptote? Vertical asymptotes are determined by input values for which the denominator is 0. 3. Given f of x equals 1 divided by x, sketch each transformation and explain your process. G of x equals f of x plus 5, which is equal to 1 divided by x plus 5. So, our vertical asymptote is at x equals 0, and our horizontal asymptote is now at 5. So then our graph is here. All right, let's take a look at B. F of x equals f parentheses x plus 5, which equals 1 divided by x plus 5. So our vertical asymptote now is at x equals -5, and our horizontal asymptote is at y equals 0. So then your graph is here. C. J of x equals -2, f of x equals -2 divided by x. So our vertical asymptote is at x equals 0, and our horizontal asymptote is at y equals 0. Now, the graph would be here and here, but the negative reflects it, so now it's here and here. All right, D. K of x equals f, parentheses 2 of x equals 1 divided by 2x. So our vertical asymptote is at x equals 0, and our horizontal asymptote is at y equals 0. So our function is here and here. All right, go ahead and finish those up. All right, let's take a look at the next page. Describe the effects of changes to the a value and b value on each characteristic when f of x equals a, parentheses 1 divided by b, parentheses x minus c plus d. The a value stretches the function vertically. The b value compresses the function horizontally. These do not change the domain of the function. These do not change the range of the function. Write a rational function, g of x, that matches the given characteristic since gets the function. The vertical asymptote is x equals 2, and the horizontal asymptote is at y equals 1. So that's 1 divided by x minus 2 plus 1. So our vertical asymptote is at x equals 2 and y equals 1. So then our graph is here and here. All right. B. For f of x equals 1 divided by x, d of x equals f of x minus 2 minus 4. So that's 1 divided by x minus 2 minus 4. So our vertical asymptote is at x equals 2. And our horizontal asymptote is at y equals negative 4. So then our graph is here and here. For f of x equals 1 divided by x, g of x shifts f of x up 4 and to the left 2. So that's 1 divided by x plus 2 plus 4. So our vertical asymptote is at x equals negative 2, and our horizontal asymptote is at y equals 4. So then our graph is here and here. All right, go ahead and finish it up. All right, let's take a look at the next page. All right, talk to talk, whatever floats your asymptote. All right, go ahead and mark off this section. Determine a rational function with the characteristics given. A vertical asymptote at x equals 3 and a horizontal asymptote at y equals 0. So that's x minus 3 plus 0. A vertical asymptote at x equals negative 7 and a horizontal asymptote at y equals 12. So that's x plus 7 plus 12. A vertical asymptote at x equals 5 and a horizontal asymptote at y equals 0. So that's x minus 5 plus 0. All right, go ahead and finish it up. And take a look at the next page. We're going to mark out this page. The teacher works A, B, and C, and the student works D, E, F, G, and H. All right, so you want to figure out the equation that corresponds to the graph. Okay, so it looks like we have a vertical asymptote at x equals negative 2 and a horizontal asymptote at y equals 0. So our equation would be 1 divided by x plus 2 plus 0, which can be written as 1 divided by x plus 2. All right, let's take a look at B. So we want to find the equation that corresponds to the graph. So we have a vertical asymptote. It looks like at x equals -2 and y equals 5. So our equation would be 1 divided by x plus 2 plus 5. All right, go ahead and finish those up. All right, let's take a look at C. All right, so here you can see it reflects. So we have the negative, and then our asymptotes are at x equals -2, and our horizontal asymptote is at y equals -5. So our equation is -1 divided by x plus 2 minus 5. All right, go ahead and finish up D, E, F, G, and H on your own. All right. You can go ahead and mark off this page. You can go ahead and do E, F, and G on your own. You can go ahead and mark off this page. You can do H on your own. You can go ahead and mark off this page. Please use these equations to answer A, B, C, D, E, F, G, and H on page 589, 591, and 593. All right. You can go ahead and mark off these pages, or this page. You can mark off this section right here. The student works 1B, 1C, 2, 3A, 3B, 3C, and 3D. And then you can mark off this section. You can go ahead and mark off this section. The student works 1A and 1B. And then you can mark off this section. All right, go ahead and get started on your assignment and have a wonderful Wildcat day.